All right. So let's get some vocabulary down here. Oh, we're also going to look at increasing and decreasing too. I forgot. Okay. So 3 different things here we're going to look at today. Okay. 3 kind of behaviors we want to be able to identify. Okay. So let's kind of go back to that function that we were talking about from the warm-up. So I'm going to re-sketch that for us here. Okay. Try and do my best. So let's see. It went from 0 to 11. So there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. I guess I go all the way out to 12 there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. Like I said, we're going to use that same graph we did. And I'm not going to worry too much. Yeah, I'm not going to worry about that. Okay. Okay, so it went from -1 to 1. Started here. Okay. Oh, wait, it stopped. Get some white out there. Okay, should stop at that. Fix that. Okay, that looks a little bit better. Not much, but better. Okay, so that's what our graph was. All right, we're going to use this to kind of answer some questions. Okay, so let's actually start with increasing and decreasing, okay, and talking about that. Okay, so does this function increase anywhere? Yes, okay. So how can we describe, bless you, where it's increasing? Like maybe let's think about where does it start to increase? Give me a value where it starts to increase. Okay, so at 0, the x value of 0, and I think I also said, like you heard you say like 0, -1, okay, or just 0. We can just use the x coordinate here. So it's going to start to increase at 0, and then where does it stop increasing? Yeah, it goes up, 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 up to 2, and then it stops, right? It kind of hits a peak there. So 0 to 2. So we'll say increasing here for our behavior. Okay, we're going to give another interval. Okay, we're going to increase. We're going to say from 0 to 2. Okay. Typically with increasing and decreasing, you don't include the endpoints because at the endpoints, it's kind of hard to say whether it's increasing or decreasing. You know, for example, here at this 2, okay, if you look at it from the left, it looks like we're increasing as we get to the 2. But then if you look to the right of the 2, what kind of behavior do we have here? It's decreasing, right? So it's like, okay, at 2, should we include 2 with the increasing because from the left it's increasing, or should we include 2 with the decreasing because it's, you know, also part of the decreasing where that starts, right? And certainly you can't be both increasing and decreasing at the same point, so it's got to be one or the other. And that's the problem we run into here. Trying to include the endpoints, it's not really clear whether we should include the 2 with increasing or decreasing, so we just don't include it at all, okay? So it's just increasing from 0 to 2. Is that the only place where this function is increasing? Is it the only place? No. Where else is it increasing? Okay, 4, 6. Anything else? And then 8, 10, yeah. Okay. Now when you have several intervals kind of like strung together like this, you want to put U's between them. I didn't leave myself very much space there. Okay, a U. It stands for union, we're joining together, okay? A union, right? We're joining them together to describe, you know, the different intervals there. Okay? All right. So now that you've seen increasing, go ahead and try decreasing. So think about what the decreasing intervals would be and list those out for me, please. Okay? Okay. Go ahead and try decreasing. Try decreasing. Try the decreasing one. Okay, so let's let's go to Patrick then. So Patrick, decreasing intervals. What'd you get here? 2 to 4. Okay, union. 6 to 8. Union. 10, 11. Very good. Okay, so that's how you describe increasing and decreasing intervals. Okay, that's how you can describe that. Okay. Very good. So let's see here. The definition for increasing, okay, what does it mean to really be increasing here? Well, I mean, what are we really looking for? What's happening to the function if we're looking for increasing behavior? Yeah, it goes up from left to right, okay? So, okay, I'm just going to do L to R like that, from left to right. Okay, and so then decreasing, what would we say for that? The function what? Goes down. Yeah, I mean, it's that simple, right? It's that simple. The function goes down. Okay, from left to right. Okay. And then I also had a third one up there that I threw in, increasing, decreasing, constant. What does constant mean? What's that? Same. Yes, the function stays the same, okay? The function neither increases nor decreases. And again, that would also be described as an interval. Did our original function here, did it have any places where it was constant? Are there any places here where it was not going up or down? Where it was flat? Do we have any flat places? Horizontal, I should say, maybe? Horizontal flat places? No. Okay? It's either increasing or decreasing everywhere there. Okay? All right, so that is the increasing, the decreasing, and the constant there. Okay. Let's see here. Yeah. So another important calculation that, well, let me. Yeah. Okay. So that was the increasing, decreasing constant behavior. We kind of lump those all together there too. Okay. Another kind of important calculation that we should be able to do is something called average rate of change of, and we'll just call this of f. Okay. Now, you've seen that word rate of change before, right? It's used, for example, in lines. Okay. What's another word for the rate of change of a line? What do we call the rate of change of a line? Slope. Slope. Yeah. Okay. It's the slope. Okay. And so, how do we find the slope? y2 minus y1 over x2 minus x1, right? Slope formula, stuff like that. Well, the average rate of change of a function is just the slope formula, basically. Okay? It's going to be, and well, let's see here. Normally when you're asked to find the average rate of change of f, you're given some sort of interval. So let's say we want to find the average rate of change of f over, let's see here, how do I want to say this? The interval a to b, okay, something like that, okay, because you're normally given an interval. What's that formula going to be then? It's going to be the slope formula. So it will be f of b minus f of a over b minus a, and that is the average rate of change formula. Okay, so it's like finding the slope, but you can use it for any function. Okay, you can use it for any function to find that average rate of change. Okay, the slope formula. And we'll do an example of that here in a second. Okay. And let's go ahead and then finish off the rest of our vocabulary here. So a maximum okay, or I'll say maximum value of f. Okay. What did we look for in our function to find the maximum value here for the warm-up? What were we looking for? The what? Highest point. Yep, highest point. So maximum value of f is just the, and we can literally just say the y coordinate, okay, of the highest point. And so then the minimum, and again, I'm saying really thinking minimum value of f. Okay, it's the y coordinate of the lowest point, right? Sorry, off the screen. There we go. And the last thing, a zero of f. Okay, a zero of a function there. Okay, and that was just the x coordinate for where the graph crosses the x-axis. All right. So, that's all of our vocabulary there for that. And so now we'll just do a couple examples. Do a couple examples. A lot of vocab here we talked about. increasing, decreasing constant, average rate of change, maximum, minimum, and then the zeros as well. Okay. Questions on anything so far? Like I said, we're just going to do maybe like 2 or 3 examples here if you guys started on your assignment. Make sure we're okay with that. So far so good? Hanging in there? I know, it's pretty dry, okay? But let's do some actual stuff now, okay? So, let's take a look here at a function. Let's just analyze this thing here. Okay, I'll go back to our old friend. F of x equals x squared. We already did the domain and the range for this, so I won't worry about that. Okay, I won't worry about that. Okay. Let's talk about increasing. I'm just going to abbreviate here just to kind of save ourselves having to write. So we'll talk about increasing, decreasing, and constant then for this f of x equals x squared here. All right. So increasing. Is this function ever increasing? Is it ever going up from left to right? Yes. Okay, that's right. So let's see here. Julian, where does it start to increase? 0. Okay. And then where does it stop increasing? So it starts increasing at 0, you said, right? And again, we won't include it. And then, well, I should go here and do it. It starts increasing here at 0, and we're going to increase, 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 increase. What's the x value where it stops increasing? Infinity. Yeah, it doesn't really stop increasing after that point, right? It keeps going, right, because of the arrow. So we'll have to say to infinity there. Yes, CJ? Because at 0, from this side, it looks like we're increasing, right? So you may want to include 0 with the increasing. But then if we come from this side, 0 is going to be where the decreasing stops. You see what I'm saying? So like at 0, from this side, it looks like we're increasing, right? But from this side, it looks like we're decreasing. And certainly we should never say that something is both increasing and decreasing simultaneously. They're kind of like mutually exclusive, right? And so that's why we don't include the 0. Okay. It turns out, actually, at the instant of 0, the function's actually constant there. Now, we're not going to worry about that for this class. We're going to say it's never constant. But at the instant of 0, at this instant, it is constant. Just for that instant, and then it's no more constant. It's going to be increasing or decreasing kind of thing. But we're not going to worry about that. Okay. That's something for more advanced math. Okay. Something that we don't have to worry about calculating for right now. Okay. So, is it decreasing, Giovanni? What do you say? Is our function here decreasing? Does it go down from left to right? Yes. Yes, okay. So where does it start decreasing? What's the farthest left that we go here for the decreasing? Yeah, very good, because it's gonna be all the way here to the left, so it's gonna start from negative infinity, and then where does it stop decreasing? 0. Very good. Okay. And then I kind of gave it away here, right? But for this case, we're never constant. So you can say never, or you can put like n/a, you know, whatever you want to say there, just to indicate it doesn't happen. Okay? No luck. Okay? Question? So the decreasing and increasing intervals, those are x intervals, right? So you always want to go left to right. And so the x values here, right, we're coming from the negative part of the x-axis. So it's going towards negative infinity, right? Yes, it's pointing up. So I see you thinking, oh, it's going up, it's positive infinity. But the x values are moving left. So that's why it's from negative infinity then to 0. Does that make sense? That's the idea. Good question. Okay. All right, let's see here. What else do we want to look at? Let's take a look at, okay, maximum. Okay, or maximum value, I guess we'll say here. Okay. Let's see here. Let's go to CJ. What do you say? What's the maximum value this function is going to hit? Infinity. So that is the same as saying there isn't one. Okay? And the idea there is that a maximum value means we're hitting a highest point. But infinity keeps going. So we're not hitting a highest point, we just keep going up and up and up and up. So there is no maximum value there, we just say there isn't one, because it keeps going. Okay? But then CJ, what about a minimum value? Yeah. Okay? 0. 0, because lowest point. Okay, we do have a lowest point. It goes no lower than that. All right, very good. Let's see here. I guess I could have underlined all of these. Okay. How about Kyler again? Kyler, zeros. Does this graph have any zeros? Okay. What is the x-coordinate of that point? Yep. Yeah, x equals 0. Okay, so we have a 0 at x equals 0. Yes, it comes down, kind of kisses that x-axis, goes right back up, but it does hit the x-axis there, so we're going to say x equals 0. Okay. And then for this last one, I do want to do average rate of change. And we'll do it from 0 to 2. Okay? Because this one maybe is the one you guys are least familiar with, right? Most of this other stuff I think is pretty familiar to you, but this one's probably the weirdest one. Okay, so if you tuned me out because you're like, this is easy, Mr. Wade, stop wasting my time, okay? Tune me back in real quick because average rate of change is maybe a little bit different. Okay? So, from 0 to 2. So let's get our points down here, right? At 0, we're right here, right? And that's the coordinate 0, 0. Okay? At 2, well, let's say there's 1, there's 2 right there. At 2, we have the x-coordinate of 2 there on our function. But what's the matching y-coordinate here? 2 is our x-coordinate, but what would be the y-coordinate right here? Not 2. Not 3. Okay, now we're just guessing now. What's the function? What is this? It's 4. Why is it 4? Because 2 squared is 4. Exactly right. You plug 2, the x value, in 2 squared, and that gives you the y value of 4. So it's gotta be 4. It's gotta be 4. Not just because we guessed 4 after saying 2 and 3, right? But because 4 is x squared, 2 squared. So it's 0.24. Okay. So how then do we find the average rate of change from this point to this point? It's the slope formula. So we'll do f of 2, which is 4. So we'll do, let me do it this way. 4 minus the other y-coordinate of 0 there over 2 minus 0. Okay? So there's our, you can think of it as y2 and y1, and there's x2 and there's x1, like that. I'll zoom in here for you. Okay? Subtract your y-coordinates in the numerator, subtract your x-coordinates in the denominator. Okay? And so we get 4 over 2, which is simply 2. So the average rate of change from 0 to 2 is 2. Okay? So in other words, we're kind of able to find the slope of this function from here to here. Okay? It's the average rate of change, so it's not the exact slope, it's an average. Okay? But the average rate of change from here to here is about 2. Okay? So we can find slopes of things that aren't flat, right? This is not a line. Before we only were able to find slopes of lines. Now we can find slopes of any curve we want to as long as we have 2 points on that curve. Let's get an approximation. Okay? All right, let me give you guys one to try here. Okay, let me give you one to try. Let's do. What kind of function do I want to give you? I won't make it too terrible there. Let's say. All right, we'll just do something like this. All right, so there's our function right there. We'll call this one g of x just to change it up a little bit. Okay, the actual function, I'll tell you here, it's the absolute value of x minus 2, like that. Okay, and again, go ahead, tell me, where is it increasing? Where is it decreasing? Where is it constant? What's the max value? What's the min value? And the zeros, if there are any. And then we'll also have you do the average rate of change. And this one I'll have us do from 1 to 2. Okay. So go ahead. Give that one a try there. Okay? So you can come up with it. And I'll come around and help if you need it. Spending more time on it? No questions? All right, let's go through it here then. See how we did. All right. Let's go to Peyton then. Peyton, are we increasing ever?
Yes.
Okay, from what to what? To infinity. Very good. Why don't you go ahead and give me the decreasing too? What's our decreasing interval? To yes, very good. Okay. Yep. Negative infinity to 2. You got it. And so then constant, not possible right here. Not applicable. Right. Just don't have it. Okay. It's never constant. Okay. Very good. Let's go to Patrick. Patrick, the maximum value. Do we have a maximum value here? So infinity, which in other words is the same thing as saying there isn't one, because we want a single value, not to keep going. Do we have a minimum value here, Patrick?
2.
So it's at 2, the x-coordinate, but what's the value? That's the y-coordinate we want there. So what's the y-coordinate? 0. 0. Mm-hmm. So we can say y equals 0 there. Okay. Let's see here. Let's go to... All right, AJ, were you able to come up with the zeros? Do we have any zeros here? Does it touch the x-axis or cross the x-axis? Does it cross the x-axis ever?
No, it like touches the x.
Okay, at what coordinate? At 2. So the 0 is x equals 2. You got it. Okay. AJ, were you able to come up with the slope, the average rate of change here from 1 to 2?
So like, oh yeah, I'm not.
Okay, so let's take a look at it. So at 1, right, at the x-coordinate of 1, this is our point right here on the function, okay? What's the matching y-coordinate here? Well, you can kind of see it's supposed to be matching up to that kind of there. But if you put it, just plug 1 in. 1 minus 2 is negative 1. Absolute value of negative 1 is positive 1. So we have the point 1, 1. And then what's the coordinate of this point right here where the 2 is? What's the coordinate of that point? 2 and 0. 2 and 0. Okay? And so we're just going to find the slope between those 2 points. That's all you got to do. y2 minus y1 over x2 minus x1. So we'll do 0 minus 1 over 2 minus 1. And so we get negative 1 over 1, or just negative 1 if you like. So there's your average rate of change. Okay. Questions on any of that? Okay. So then, what I've got for you here, and there's a few books to spare in the back there. All right, I'd like you to work on this from the book here. Page 18 in the book, or section 1.2. So 1.2, page 18, numbers 1 through 5. Okay, 7a and b, and 8 through 10. Okay. So again, your choice. If you want to pull up it up on your Chromebook, okay, you can look it up at the MyHRW website, or you can pull out one of those books in the back there and just snap a picture of it. Or if you have your own book, that's fine. You can use that too. Okay, but that's what I'd like you to work on here. Okay, so go ahead and get that out. Get started on it there for some practice. And I'll come around and help you too as soon as I get the video done here.